This Regents chemistry video is on moles as an introduction to what they are, and also about a few basic conversions with moles. So before you watch this video, what you need to know is how to convert units, so how to do dimensional analysis or unit conversions. So I've got a video up in the units and measurements section about how to convert units, and you'll need to be able to do that before you can convert moles. So if you can't do that, stop the video right now, go watch that video. Make sure you refresh yourself on unit conversions, and the other thing you'll need to be able to do is calculate formula mass. So if you're having trouble with that, just go to the formula mass video that's also in this chapter and make sure you're fresh on that as well, because those will be two very important concepts for this video. So to get an introduction with moles, what a mole is a quantity. So it's this quantity 6.02 times 10 to the 23rd. That's also called Avogadro's number. So a quantity, just like a dozen is a quantity, we know a dozen means 12. So a dozen eggs would be 12 eggs. A dozen bagels would be 12 bagels. 1 mole of atoms would be 6.02 times 10 to the 23rd. So this number, Avogadro's number, this mole, is just a quantity, just like a dozen. So a dozen means 12, a mole means 6.02 times 10 to the 23rd. So a mole of atoms is this many atoms. A mole of molecules is Avogadro's number of molecules. So we can ask ourselves the question, how much does a dozen weigh? Well, you might think this really depends. Because basically, we don't know what we're talking about here. How much does a dozen weigh? Well, a dozen of what? A dozen eggs? A dozen bagels? Those are going to weigh different things. So we can't say a dozen has a certain weight. It really depends on what it is. So how much does a mole weigh? Well, it also depends. Because if we're measuring out a mole of sodium atoms, well, that's going to weigh a different amount than a mole of hydrogen atoms. If one hydrogen atom weighs different than one sodium atom, then 6.02 times 10 to the 23rd hydrogen atoms would weigh a different amount than 6.02 times 10 to the 23rd sodium atoms. So it really depends on what we're measuring. So we can't say a mole weighs a certain amount. It depends on what we're talking about. So let's do a couple of conversions here. We're going to start by converting between moles and particles. So to convert between moles and particles, we're going to use Avogadro's number, because 1 mole, MOL is the abbreviation for mole, so just to clear that up. So 1 mole is 6.02 times 10 to the 23rd particles. And this could be atoms, it could be molecules, it could be ions, it could be really any particle that we might be talking about. So to convert back and forth between these, we're going to use this conversion factor here. 1 mole is 6.02 times 10 to the 23rd particles, so that's the number we're going to use here when we're doing our conversions. So this is very important. To go between moles and particles, we use Avogadro's number. So let's try an example out here. How many sodium atoms are there in 3 moles of sodium? Well, this really is just a simple unit conversion. So again, if you need to refresh on those, go watch the unit conversions video. But to do a unit conversion, we're going to take the number that we start with here, 3 moles, and we're going to multiply by our conversion factor. So we have moles on the top here, because really we could put this over 1. So we've got moles on the top in the numerator. We want to put moles on the bottom in the denominator to cancel it out. And then, so what we're looking for is how many atoms. So we put atoms on top. And then the conversion factor here is going to be Avogadro's number. So 1 mole is 6.02 times 10 to the 23rd atoms. So we just multiply straight across the top, straight across the bottom here, and we get, this should give you 1.8 times 10 to the 24th atoms. So that's going to be our answer here. 1.8 times 10 to the 24th atoms is how many sodium atoms we have in 3 moles of sodium. If you pay attention here, this really could say potassium, and the answer would be the same, because we're just counting the number of particles that we have here, atoms to moles. So this is how many atoms there are in 1 mole. So if this is how many sodium atoms are in 3 moles of sodium, or how many potassium atoms are in 3 moles of potassium, the answer would be the same, because we're not taking the mass here. We're just saying how many particles do we have. So that's just using Avogadro's number regardless of what the compound is. So the next question here, we're just going to go the other way this time, going from molecules, particles, to moles. So again, for the unit conversion, we're going to take the number that we're starting with, 2.41 times 10 to the 24th molecules, and we're going to convert to moles. So we want to put molecules on the bottom and moles on top. This way, molecules cancels with molecules. We have Avogadro's number, 6.02 times 10 to the 23rd molecules in 1 mole. So here, if we multiply straight across the top, we get 2.41 times 10 to the 24th. If we go straight across the bottom, we get 6.02 times 10 to the 23rd. So then we just have to divide this out to get our final answer, and our final answer here will be 4 moles in this quantity of sulfur trioxide molecules. So again, another unit conversion here. We're just using the same conversion factor, how many molecules or particles or atoms are in 1 mole. So going from moles to particles or particles to moles, just to sum it up, we're going to just use Avogadro's number one way or another, whether the Avogadro's number is on the bottom or the top of this fraction, whichever way cancels your units out properly. So there's a couple of examples here that you can try out. If you'd like to pause the video and try these out on your own, I'll give you the answers. In 1.5 times 10 to the 24th magnesium atoms, there are 2.5 moles. And in 4.2 moles of fluorine, we have 2.53 times 10 to the 24th molecules. So if you happen to get these incorrect, go back to the first 2 examples, review the process, and try it again, and see if you can come up with these answers the next time. So the next thing we're going to do here is converting between moles and grams. So to do this, we use the formula mass. So between moles and grams, it's going to be formula mass as our conversion factor. So what the formula mass is, we've kind of talked about this already. We've used atomic mass units so far and said that the formula mass is how many atomic mass units are in 1 molecule or atom of whatever we're measuring. So in this case, we're going to use formula mass as the mass of 1 mole, and this mass is going to be in grams. So you can think of the formula mass as how many grams are in 1 mole of whatever substance we're talking about here. So to go between moles and grams, or grams to moles, we're going to just use the formula mass. And so you can already tell, this is what we talked about before, how much does a mole weigh? Well, it depends what we're weighing, whether it's sodium or potassium or chlorine. It really depends on what we're talking about as to what the weight is going to be, and that's why we use this formula mass in grams per mole. So how many moles are in 24 grams of potassium chloride? So what we need to think about here is what is the formula mass, because that's what we're going to use to go from grams to moles. So our formula mass here, that's the first thing we got to do, is just calculate formula mass. So the formula mass of KCl would be the mass of potassium, which is 39.1, plus the mass of chlorine, which is 35.5. So our total mass here is 74.6, and that's our formula mass. So this is what we're going to use as our conversion factor to go from grams to moles, because that's our ultimate goal here, is to figure out how many moles are in this many grams. So we're just going to do another unit conversion. So far what we've done is just figure out what our conversion factor is, so we still have to do the unit conversion. So to do the unit conversion, we take this 24 grams, which is our original measurement, and we multiply by our conversion factor. Here we have grams on top. We want to get rid of grams and get to moles, so moles go on the top, and 1 mole in this case is 74.6 grams. So this formula mass, that's what it tells us, is how many grams are there in 1 mole of whatever substance we're talking about. So here grams cancels with grams. We multiply straight across the top, 24, across the bottom, 74.6, and then we just have to divide this out, and this will give us 0.32 moles. So this is the same process as before, we're just doing a unit conversion. The only difference is now we're using the formula mass per mole instead of the number of particles per mole. So to go between grams and moles and back to grams, it's going to be using this conversion factor of the formula mass, which will vary based on what the substance is. So in this case it was KCl. That's how we got this 74.6 for our formula mass, and that's what we use down here in our conversion factor. So we can also go the other way and say how many grams are in a certain number of moles. So either way, if we're converting between grams and moles, the first thing we have to do is find the formula mass. So for lithium sulfate, we're just going to remember with the formula mass, we're just going to add up all the parts. So we have lithium, which is 6.9, and we have 2 of those, plus 1 sulfur, which is 32, plus 4 oxygens, and they are 16 each. So if you add this up, this is going to give you a total of 109.8 as our formula mass. So this is what we're going to use as our conversion factor. So again, with the unit conversion, we take our original measurement, this 3.7 moles, and we multiply by our conversion factor. We have moles on the top, so we got to put moles on the bottom. So 1 mole is 109.8 grams. So we multiply straight across the top, and that will give us 406.3 grams. So again here, we're just using the formula mass. This time we put the formula mass on the top so that we canceled moles with moles. Last time we put it on the bottom so that we canceled grams with grams. Again, it just depends what you're looking for. So here we started with moles and we're looking for grams. So again, with the unit conversions, you just want to cancel out your unwanted units in a way that gives you your desired units. Again, if you're struggling with that, just go back to the unit conversions video and brush up a little bit. So again, between grams and moles and back to grams, what we're using is the formula mass. So a couple of final examples here. This is using just converting between mass in grams and moles. So again, pause the video if you'd like to try this out on your own. But basically, the answers will be 15.2 grams for 5.1 moles of barium bromide, and for 250 grams of copper chloride, this will be 1.86 moles. Again, if you happen to get these answers wrong, just go back to the last couple of examples using formula mass to convert between grams and moles, and then try it again. Alright, I hope this video helped you learn about moles, and if you have any questions, just go back to the beginning of the video and try and work some of these examples again. Thank you.